Alright, time for another DraftScience video presentation. Tough choices. Horrible video to respond to, or a horrible video to respond to, or a horrible one to respond to. Yeah, there was 3 of them. Whatever it is. Dr. Dave, I don't remember what his name is anyway. Dave will explain. Was kind of a boring video, actually, so who cares? I mean, it just proves momentum, which isn't the argument. The argument's kinetic energy, and he really doesn't have a kinetic energy video. So that was kind of forget it. Then the Fermilab thing, I mean, just a silly video on, the eraser experiment. Again, diagrammed so crudely and imprecisely, the same as their double slit bullshit. Just so bad. And then there's this pyrrho crap. So apparently Stephen Bro asked for him to restate what he restated already and make exactly the same use exactly the same tricks and all that kind of crap. So there's really just nothing. There's no reasonable feedback in any of this at all. So I'll just go through it just from perspective, rational perspective versus their mush. So Pyrrho will do all this convoluted stuff, but he starts with the bastardization of Newton's argument, and he calls all this classical. Again, he's saying that Newton would agree, when clearly Newton was alive when Leibniz proposed this mv squared stuff. Newton thought it had no value whatsoever, no meaning, no anything. He didn't overtly get into the argument. He had his surrogates do it, but it's clearly not Newton's physics. It's not something Newton overlooked. He was told about it and said, too silly. Alright, so Newton's argument is F equals the change in your momentum over time. Now, time is anything you want it to be, right? You're just saying, if I want to know the rate at which the force is hitting me, so I could weigh 100 pounds, and I could hit you with 100 pounds of weight. But I'm going to hit you for a period of time. The longer I push on you, the more force I'm applying. So it adds up over time. The weight on you will slowly but surely suffocate you, we could argue, or something like that. It's an amount of force being applied to you. Now, as I pointed out, with like a piece of wood, you could apply a force, and it could do nothing. The wood just bends a little bit, it absorbs the force, and it keeps absorbing it like weight, like gravity, like putting a weight on a board, and the board will bend, and the force is still pushing on it, but it's not doing anything because the board has dealt with, it's created a counter force of its own in terms of the stretching of its fibers, and can do it for a very long time. Or I can hit it with a higher velocity, that is more weight in a smaller area, and I'll break the board. Okay, so this is just, we should all be able to agree on that kind of stuff. Should use the eraser because I don't want to create any extra dust in this cruddy environment. Anyway, so I'm going to keep arguing that all of this is just weight. That force should be understood as pressure. It's just a weight. And what we're basically saying is you're made up of units, of mass, that can be given a velocity, which will be a weight, a pressure they can apply to something when they hit it. So if you weigh 100 kilograms, I hate to have to use the English thing, but we'll do it. Anyway, the point would be is that you have 100 units that can be given, a velocity, and therefore apply a pressure, a weight, on a surface, on something. And so you're really just saying that we've basically weighed you in gravity and found out how many units of mass you have, and now we know how many units of mass you have, and now we're just going to give those units of mass velocity, and when you add up the unit plus its velocity, you'll get its pressure or its weight that it can apply to something. So it's not very complicated. Alright, so a Newton is defined, and again, there weren't any Newtons and there weren't any joules when Newton was alive. There was just an answer to the question, a number, 5. All right, so it was 5 units of energy, pressure, force. Okay, force wasn't understood to be explicitly just weight, but it sort of is just by the units we have. So a Newton is you just take 0.1 kilogram and you just drop it 1 meter, okay, and when it hits the scale, okay, it'll deflect the spring, okay, and tell you how much it weighs. That's what you're going to do. You're basically just weighing it, and that's the weight of, so a Newton is a stick of butter, which is about 100 grams, or 1/10 of a kilogram, and you drop it, and you can understand that when it's just sitting on the scale, it's 100 kilograms, it's 100 units, and when it lands, after falling, gaining a velocity, okay, it's going to end up hitting the scale, and it's going to have some new weight, it's going to be higher, obviously. Okay, so that's the definition of a Newton. It's just a weight. It's just how much does something weigh when it, 100, how much does 1/10 of a kilogram weigh when it lands on a scale after falling 1 meter? Bang, Newton. So I've compared it to, well, I didn't compare it, no, that's a joule. Oh, shit. Sorry. A Newton is just 100 grams, okay? A Newton is just the weight of a stick of butter, and then a joule is dropping the stick of butter 1 meter. Oh, I should start the video over, but nah. All right. I like so much. I'm just so unenthusiastic about any of this because there's no counter argument to any of the history. There's no counter argument to the shenanigans and the gimmicks and the stupid math. There's absolutely no counter argument to the fact that we really are just talking about forces being pressure applied to things. Period. And you can sort of understand that. A bullet applies a pressure, but it applies a pressure to a very small area, okay? And it applies it by having a very high velocity, which means it can dissipate its energy very quickly because it can give the pieces it hits a very high velocity instead of a low velocity. So it doesn't have to hit as many to get rid of all of its energy. If you could give people $10 and then you had to give them $1 bills, you can understand that if you had to hand out $1 bills, it would take so much more time than if you could just get rid of the money by handing out tens. That's a bullet is handing out $100 bills. It's handing out big chunks of energy, where something moving, a kilogram moving 1 mile an hour, is handing out pennies. So it takes it a lot more time to dissipate its energy. Okay, so, all right, so the simple way of looking at this equation, again, this time thing is what they're going to screw up. All right, so they're going to pretend that, Newton was saying something specific here about time, when he wasn't. He was just saying it's a change in your momentum. Because as I've pointed out, I can get rid of time by just saying, I just want to know the total. So the total force, not the rate. So I don't want to know how much the total force is when I leave the 100 pounds sitting on top of you. I just want to know after it's all done, how much force was it? Well, time is going to be needed after it's all done. So that's another mistake on my part to say it that way. All right, so I want to know the force final. Okay, the final total amount of force that is applied to something. Then all I need to know is what's the change in its momentum. So I can just make the unit the whole time. So if it's 16 seconds, right, I can just say, oh, well, the unit of time I'll use is 1 unit of 16 seconds. And then all I have is the change in the mv. Again, momentum is just m, mass times velocity. So that's what Newton was basically saying, is that force just basically equals the change in your momentum. So if you want to know what the total force is, you just make the units of time the entire amount of time, and then you'll know the total change. And so it works for time too. But if you want to know it by a rate, then you can put in 16 seconds, and you can divide the mass times the velocity by the number of seconds, and that'll tell you per second, all right, per second, what the force will be. It's not going to be the total force, it's going to be the force per second. That's the rational way to look at this equation. This equation isn't saying F equals ma, especially when you're going to make acceleration into a silly, okay, equation, because you're going to take something really simple, which is acceleration is just saying, now we're going to just be very specific, and we're not going to bother with mass times velocity. We're just going to pay attention to velocity, and we're going to say, well, how do we measure velocity? Well, it's distance divided by time. So a change in your distance, okay, over the change in your time, and it's not time squared. Okay, there's no reason why you would square the time to get your acceleration. Your acceleration is going to just be a number. It's going to be like 3 miles per hour. You know, it's not going to, you know, I should put it in kilometers, kilometers. Kilometers? No, meters. Yeah, okay. All right, so we'll just play the same mistake, you know, the same bullshit. I don't even know if it's a mistake. It's clearly not logical. So that's what we'll go with. It's not logical. And the whole thing is screwed right from this very beginning. So as soon as they say F equals ma, we know their a is a nonsense. It doesn't really have to do with a change in velocity. It's some other weird thing, because they made a change in velocity divided by time squared for no good reason.
Take this as a moment in time. We can talk about that, but when you start doing all the deltas, delta d means d1 minus d0, so two different values. And if you take a
right, so you're just comparing your time, okay? I mean, how fast were you going here, okay? So all you want to know is you had a velocity, and now your velocity is going to accelerate or decelerate. So now your velocity here is either velocity plus or velocity minus. And you're just going to subtract these numbers and figure out, well, how much did my velocity change? And that's it. That's your acceleration for that period of time. That's what you did. That's all it is. There's no reason to square anything.
Delta in the delta, then you start to get a lot of D1, D2, D3, D4, all of these, and it starts to look complicated. And that'll matter when speeds are changing and things like that. But in this case, we can get the equation we're looking for. F equals ma. What does that mean? Well, F is isolated here. It means if I knew the mass and the acceleration, then I could calculate.
Right, and if you knew the mass and the velocity, you can calculate the force, because it's the same thing. If you want to know the force that's changing your velocity, yeah, then it's F equals ma. But if you want to know the force, okay, that created your velocity, then it's F equals mv.
Calculate the force. But what was acceleration again? That's velocity over time. And velocity, of course, is distance over time.
Right, so you could have just stuck with the first one and you would have been just fine, but you already know the velocity, change in velocity. So he says we're not going to use the delta, but the delta would be important here. It's the change in your velocity over a period of time. That's your acceleration. So if you know the change in velocity, then you're done. You don't need to do anything else. You're done. You don't need this velocity equals d over t thing. But obviously that's how you measure a velocity. How much distance in how much time. So you take your distance and time number and you have to subtract it from something though. This isn't going to tell you your acceleration. Just saying v equals d over t isn't going to tell you, okay, anything, because it's not telling you your relative change in your velocity. It's going to give you a number for what your velocity is currently. It's not going to give you a number that's going to be able to tell you how much did your velocity change. You have to compare two numbers. So your velocity was 5 miles an hour. Now your velocity, you test it, d, divided by t, and now it's 4 miles an hour. Well, if you don't know the 5 mile an hour number, how can your acceleration is obviously minus 1 mile an hour. Your acceleration is not going to be derived this way.
Right, so that means acceleration equals velocity, which is distance over time over time.
Your previous velocity, so it's not over time. So right there, what do you mean it's over time? That's not true. It's over your previous velocity. You have to divide one into the other. Just dividing the whole thing by time doesn't make any sense. So right there, that's
which equals d over t.
Okay, so here's where we get it. So this is where he does his little cross multiplying trick again. All right, so he takes this, okay, which is, look, okay, he's putting one formula inside another formula. So he's saying distance divided by time will tell you your present velocity. It's not going to tell you anything else because you're not comparing it to anything. So it's not your acceleration, it's your velocity. So this is essentially just saying v. All right, so we'll just put in a circle what I would say the equation is. All right, so acceleration equals v. And then he sits there and just says, well, now we're going to put that because it's d, is he's saying v is d over t. Right? And we already know that it doesn't tell you your acceleration, right? So velocity, it's change in velocity. So that's where he took the delta t out, the delta v out, and it's very deceptive because it's now you can't see that this is a change. It's not the velocity, it's your change in your distance and the change in your time. So again, he cheated the equation. Anyway, so he puts it over some generic amount of time. So this time and this time are going to be the same times. So he's using the same number in the equation twice. All right. So let's just go with all right. So anyway, let me just go his way so you can just see it bigger. Okay. So he has a equals. So he has dt. Okay, over another fraction is what he's going to turn it into. So he has time here. So these two times are presumably the same. But let's go further.
Times 1 over t, which equals...
Okay, so this is where he just cross multiplies. So what he did was he basically says, I'm just going to put a 1 under the t to make two fractions. And then I'm going to do this and this. Okay. That's the mathematical trick. I'm going to multiply these two and these two. And so that's where he gets the t squared. Okay, and then he gets d1. So he gets d and t squared. Okay, so but that's the gimmick, right? Because he didn't put a unit here. If he would have put a unit here, all right, then you would have had dt, right? All right, let me just write it out as he did. So he has d over time, and then he's inverted this fraction, so it's 1, okay, over t. And so now he's going to sit there and say it's t squared down here, all right, and it's d up here. Now, if he had put a unit here, right, if he would have put meters here, or any unit, right? So everything has a unit. Everything's in a unit form. So these numbers would all be 5 meters, and this would be 5 seconds, and this would be 5 seconds. And why wouldn't this be 1 second, right? Kind of obviously he has denied the existence of a really important unit. This 1 doesn't have, it's not in units. I could make this trees, and then I could end up with down here. Okay, you'd end up with, it gets rid of the 5, so that's just going to confuse you. Well, it really won't. I shouldn't use because trees have the same symbol, right? So we'll make it bumblebees or something. Yeah, so I'd end up with a b here. Okay, so I'd have db because I decided to have a unit. The unit was down here. That's completely inconsistent. Well, it would be up here when I'm cross multiplying, right? So, so that's the gimmick. This should be a second here, okay? So that's the simple fix. So if you do this simple fix, it works out just fine. You have seconds down here, you have seconds squared down here, you have second here, you just cross that one out. Well, you just cross out the square and cross out one of the seconds here, and then you have distance over seconds again. You have meters over seconds. So you're back to a rational equation. So that's it. That's the cheat. And from that cheat, once you have this squared in here, this time squared, then you're going to have, it's going to just keep making messes. It's wrong, it's inaccurate, it's incorrect, it's the wrong answer, it's not right, there is no second squared. And once you inject it, then it's just going to break everything now on. So the foundation's broken, everything else will be garbage. So I already went over this, and probably better than I just did, but who cares? So that's the gimmick. So the rest of it's just the same bullshit. So now I've got this squared in there, and now I'm just going to work it into the equation until I can finally get it where I want it, which is v squared. And that's all that's going to happen here. So he's just going to play games to get to, well, he doesn't even get there, frankly.
D over t squared, because when you multiply fractions, you just multiply the top and the bottom.
Right, so it doesn't make any sense on its face. You're just saying, why would I take the time and square it? So I have 4 seconds. Why would I make it 16 seconds? Oh, because I can make this number bigger and bigger by making the denominator bigger and bigger, right? That's the way it works, right? Bigger the number, the smaller this number becomes. Smaller the number, the bigger the outcome number becomes. Well, it doesn't matter. It's obviously for that purpose, as will be seen.
So this is the important part here. A equals d over t squared.
Right. So so just understand, it went from v over t, something simple, okay? Then it went, first you have to do the v into another fraction, then you put the fraction over this other crap, and you end up with this squaring crap. So does it make any sense? The distance somehow divided by time squared. Well, why wasn't the velocity divided by time squared then? Because you're basically just saying the same thing. The velocity is itself already been, you can already know the velocity is 3 miles an hour. Why would I put t squared under it?
Jesus. So that means that this equals m times a is d over t squared. Now, notice when we're
So just notice that it doesn't make any sense. That's all you have to notice, right? You know the acceleration isn't going to be answered with distance, let's say 5 meters divided by time squared. It took 4 seconds to do it, so it's now 16 seconds. Why would I do that? It doesn't make any sense. It's not going to give me a rational acceleration number, so it doesn't work. So if you put real numbers in here, it already falls apart. It already doesn't make any sense. But you won't do it with real numbers. You see, real numbers will reveal that you've just changed the rules entirely. If you already knew all these quantities and just filled this in with real numbers, this isn't going to make any sense.
multiplying the time, there's seconds in there, but they're going to add up into the unit of force when it's the force that's isolated. Well, let's say we had the force and the mass and the time. We didn't.
Let's say we had everything, and your formula won't work. That's the simple truth. Won't work.
Have the distance. In other words, if we had a rocket pusher. There's a rocket pusher over here.
So this is a terrible example. So I'll just point out that Professor Lewin will tell you the force changes depending on how fast the rocket's going. So the same amount of thrust will produce a different amount of force depending on how fast you're already going. So if you're already going 1,000 miles an hour, your gasoline or whatever you're burning at a constant rate will actually produce more joules of energy in terms of more velocity. So it doesn't even work. That's how bad the equation is. It doesn't work. Overtly doesn't work.
There's a little pusher up here. It pushes your little...
It's like saying you could change gravity by changing how fast you're going. You're going to change how much you're going to get affected by gravity, and you can't. So it's a silly notion that somehow your previous speed will increase how gravity affects you. It won't.
Thing with your window, because it pushes it. Then when it stops, it turns around, you just go flying through space. And the rocket has a constant force that applies, F.
Right, but it's not constant. So I'm just saying the kinetic energy formula means that force will not be constant. Can't be. That's the paradox this stupid formula creates. It creates a paradox where you have a constant force that isn't applying a constant force. Somehow, when the rocket just takes off, the force is really weak. Somehow, when the rocket's already flying, the force is really strong. And it gets stronger and stronger. The faster you're going, the more the force gets more and more power. Doesn't make any sense at all.
And, we know what the time is because we want to know the number when it's been,
It makes more joules of energy. It weighs more. Somehow the force makes you weigh more. So even though it's a constant rate of force, it somehow is giving you more and more weight. I should have just done the weight thing from the beginning. Just say, look, all of these things, it's just weight. A joule is a weight. All right? It's a Newton falling 1 meter. It's a weight. It's an impact. Everything is just that. It's just your mass moving. When your mass moves, it weighs something. It doesn't weigh anything when it's not moving. So if I push against something and I'm holding it in my hand, I've ceased it to be obviously moving. But I'm obviously applying the counterforce to stop it. So it is moving, in fact, and I'm applying a counterforce to stop it. And all you're really saying is now I'm going to give those units, by letting it go, I'm going to allow them to create a weight in a direction. Okay, I've made them weightless in the sense that if I put a scale under my hand, it doesn't weigh anything because I'm applying the counterforce, stopping the thing from weighing something. You can't weigh something if I'm holding it up, right? There could be a stool. I put a stool over a scale. All right, you step on the stool. Well, you're not going to weigh anything on the scale, right? I mean, come on. So until I let your velocity, until I allow your pieces of matter to have velocity, they can't weigh anything. But they do have a rest mass. I mean, they have a rest units, and that's the number you have. We found out from gravity what your rest units, once they're given a standard velocity, what they weigh. So we now have something to compare everything else to, and that's all you're doing. So if you push something with 9.8 meters of pressure per second, that is every second, and it's continuous, and you're able to push every one of the little bits of you, okay, that will duplicate gravity in a direction. So that's, a space station spinning. Lots of examples of artificial gravity. And all it's really doing is making you weigh something by giving you velocity in a direction.
1,000 seconds. Well, how would that work? D is over here. Well, we have to isolate D. Now, this is one of the easiest things that always seem to confuse other people about how you move variables from one side to the other. Remember, this equation is like a teeter-totter, right? And it's perfectly balanced.
So it isn't. Okay, it's not going to get a right answer. These are two different equations, essentially. So it's all crap. But anyway, let's go. There's no point. It's just this I'll play a little more.
Right now. How do I keep it perfectly balanced? How can I move the M over to this side and get A alone? And the answer is you can add, subtract, multiply, or divide either side as long as you do the same thing to the other side, right? So 2F equals 2M D over T squared. Right, I can just multiply both sides by 2. That'd be fine. But why would I want to do that? Well, I wouldn't. But if I want to get D alone, I can multiply by T squared on this side. And I have to do that on this side too. These cancel out. Boom. It's moved over there. Okay, now I still have MD on this side. And F, I'll put the T squared second on that side. Because, of course, I hope everybody remembers when you have multiply numbers, you can...
Right. So what's the difference? Exactly. So this is just a way to make it visually more obvious what your task is. But that's it. So now you'll put D on one side and say it equals this slop on the other side. And it's going to be slop.
Multiply them in either order. Now I want to get the M over there. Well, I can divide this side by M and this side by M. And then those cancel out. And I have D on this side. And F times T squared over M on that side. When we have the isolated variable, we like to put it on that side because it looks nicer to us. Now, if I have the mass, right, the mass of this thing that's getting pushed, and I have the force, so this thing has a mass, right, let's say it's 1,000 kilograms.
So again, this won't get the right answer, because of the kinetic energy formula explicitly. It won't get the right answer.
And the force, well, it doesn't matter. I'm not going to make them numbers for all of them.
Depending on how fast the thing was originally going, this, again, it won't get the right answer.
And then the time we want is 1,000 seconds. Well, now I can plug those all. I guess I have to make a number. Let's say that this is, oops, I hate when that happens.
All right, so anyway, there's no physical evidence of any of this stuff. So then again, that's the argument. There's no physical evidence them demonstrating any of this to be coherent or reasonable. So then he says the joule is equal to a kilogram over meter squared over time squared, which again, the joule is just 100 kilograms falling 1 meter. That's a joule. Yet they'll write all this crap. For what purpose? For the very purpose that they have, which is they love to square things for no good reason. I mean, two things over each other squared. I mean, well, come on.
Distance that is seeing the effect of the squared, right? It's the distance that the more the time, the faster and faster the d is going, so the effect of time is compounded.
It doesn't, the velocity and the distance are the same thing. They're going to reveal the same thing. They're reciprocals of each other. The velocity is how much distance you're traveling. The distance is how fast are you going. I mean, it's, you know, you can't make them into different numbers or in different ratios. Faster velocity means more distance. Less velocity, less distance. I mean, all right, then he does this crap in a little box, which again, just horseshit. So we'll just do a little bit of this because it makes it obvious.
So that's the force. We're going to times 5 seconds squared, right? And then.
All right, so he's put the force with all of these stupid extra units in it, and then he's going to do this. Let's cross out units, and then he doesn't even remember. He's supposed to multiply the actual number he didn't cross out.
Oh,
so.
I'm sorry. I know what I did wrong. I was looking at this. This is not. This is not joules. Sorry. This is newtons. Okay. Made a mistake. So that's newtons, and newtons isn't meters squared because see the units weren't working out. Okay, so it's kilogram meters because a newton.
Yeah, like that's the difference between a newton and whether you have a square on here. When now the difference is that a newton is. What is the difference? Yeah, well, as stated, a newton is just a weight. And the joule is pretending to be something other, but it's really just another weight. It's just the newton falling 1 meter. How much does it weigh after it falls 1 meter? That's a joule. So again, they could just all put this in weight and it'd be so much easier. All momentum is just a description of how heavy you are. If you're going 30 miles an hour in your car, your front of your car, when it hits a scale, is going to weigh something. There's an amount of weight that your car is going to hit another car with or hit anything with. It's hitting it with a weight. There'll actually be pounds per square inch of different, kinds, just because different parts of your car will hit different things at different times and in different ways. But there's going to be an actual pounds of pressure applied to the other car. I dropped my mouse. Ugh. Like I said, I just have no. This is just redundant, and again, so this is what they think physics is. Physics is math gimmicks. It's not showing you an experiment where it actually works.
A newton, the unit of a newton is a kilogram, meters per second squared. Okay. Because the units, see, you can check the units to see if you're making a mistake. Okay, so this is on top, and that's on the bottom. So let's deal with the top. First of all, this is going to be, see, what's the easiest way for you guys? I mean, basically, there's some interesting things going on. I want to multiply this top out first, so we have 500 kilogram meters per second squared times 25 seconds squared, because 5 seconds squared is 25 seconds squared. And this is all over 1,000 kilograms.
So again, another gimmick in the sense that he puts it in parentheses to say this is a square of the 5 and not a square of the seconds, but he's going to make it the same thing, so it doesn't matter. He says now he's 25 seconds squared. It's like he's squaring it again almost, right? I mean, that's what that sort of would imply to somebody.
These seconds divided by that seconds cancel out because that's 1.
Right. So you canceled out the units, but you didn't cancel out the number. So he never multiplies the 500 times 25. So his answer is completely off by,
the
25.
And that leaves us with
times wrong.
D equals 500 kilogram meters over 1,000 kilograms.
Right, so this should be 1,200 here, 12,000. So this number should be 12,000. 25 times 500 should be 12,000 and a half. And so then it would be a completely different number, wouldn't it? Yeah, it'd be a completely different answer. So anyway, who cares? That's a irrelevant little mistake. But just this whole bullshit is just that. It's just bullshit. So I'm just not going to waste any more time. We'll play a little bit at the end where he gets all goopy about what, natural philosophy horse shit, that some of this bullshit has something to do with reality, when it's an evasion of reality. Again, no experimental evidence demonstrating any of this crap. Newton was right. This crap is wrong. It's invented deliberately on purpose as a religious objection, to force, essentially, Muslim crap, or whatever you want to call it, Christian crap, Muslim crap. A guy who believed in things called solitons and monads, that these were real things in the space, little ghosts. Okay? That's the guy who invented this horse shit.
Right, which is Joule, and so it connects like all of the kinds of physics. I mean, all quantum mechanics is doing is it has conservation of energy. It's the same kind of energy with the same kind of unit.
Okay, so it's not the same kind of. They have a huge duality problem, particle-wave duality. So all of quantum mechanics is about stupid dualities that can't make any fucking sense. So you have an energy duality. You have momentum, and then you have this thing called kinetic energy. They aren't the same thing. It doesn't give the same answers. It's completely breaks all continuity and all consistency. It creates free energy scenarios. Either if you don't conserve momentum, then you're obviously creating free momentum or destroying momentum. And if you don't conserve this kinetic energy, then you're obviously creating free kinetic energy or or destroying kinetic energy. It just doesn't make any sense. It breaks all the rules about conservation, and it certainly completely breaks any notion of Newton's third law meaning anything, because you can just change your purpose. You can just say, well, I only consider momentum, and then Newton's third law works. But if I could, then in another case I'll just do kinetic energy, and then Newton's third law works. But there's no consistency. When one works, the other one doesn't.
And it's just on a nuclear level and different physical effects, right? Because space, time, and mass don't say there is or isn't a photon. It just says that if there is a photon, you'll know because we'll be able to measure it in terms of space, time, and mass. Right? In quantum mechanics.
There's no space, time, and mass bullshit. You'll measure it because it applies pressure to electrons. It weighs something when it hits them, and it causes them to move.
Mechanics is the same thing. So that part of the natural philosophy of this physics, is solid. There is no controversy. They all hook together that way.
Okay, they don't hook together. There's obvious duality problems. This is just baby talk to sit there and deny the fundamental problems that exist in any kind of logical continuity. You have particles that interfere with each other, and they're superimposed, and yet they're in a universe that's full of forces banging into them, and somehow they don't reveal themselves until you decide to reveal them, that somehow they're not outed by the constant stream of force that's constantly hitting them. So somehow they stay entangled for whatever period of time you choose to make them entangled, when they're automatically going to be having their picture taken by things like gravity. Schrödinger's cat has no time to be alive or dead in some superposition, because gravity is taking a picture of the cat all the time. So it's already been outed. It has to be one or the other because gravity saw it.
So after force, you have momentum and energy. Momentum is when you take a force and you apply it for a certain time. That
doesn't make any sense. So momentum is a certain force. It's not. Your kinetic energy says the force is squared. It's this huge, gigantic increase because you change the velocity. And mass is irrelevant.
And you'll get a momentum because it's force times time. And energy is when you take a certain force and you apply it over a certain distance.
So again, just horse shit. That you can separate velocity from distance is just horse shit.
Then you get energy. So, and in those layers,
that somehow they can be different numbers. They don't have to be directly tied to each other. Somehow you can have a high velocity and you don't get much distance, or you can have a low velocity and go a lot of distance. No, there's never going to be any incontinuity between the two numbers. So that's just bullshit.
just a simple, it's like, depends on how you want to count the layers, but it's distance, velocity, acceleration. But to me, that's one layer. Because so far,
So again, and distance, just again, theoretically, everything travels, without friction. In that, so that's we're always, everything has to be measured based on what would it do if there wasn't friction. So when you're measuring a distance, you have to measure its distance in terms of there's nothing degrading its velocity. It's not traveling through clay, or it's not traveling through something that's going to degrade your results. So you have to make the experiment as frictionless as possible to get any kind of accurate distance numbers. And when you do that, then it will reveal that this kinetic energy thing is complete nonsense, because the numbers are preposterously silly.
that's all distance and time. And then you have mass, and that's the force layer. And after that, you have
the force layer, whatever that means. So whatever. You just have masses moving, and that's weight, and that's pressure, and that's energy. Period. Movement is energy. Period.
mass over distance, mass for a distance and mass for a time. And that's, if you understand those concepts, then that is classical physics.
All right. So anyway, none of this is classical physics. None of it's Newtonian. It's just a big lie. Newton would not like any of this. Newton wouldn't be playing your game, blah, 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 blah. Because Newton knew that it's really just about weight. That's all you're creating is weights. You're just giving something more weight by giving it a velocity. Period. But anyway. Yeah, sorry, just a junk video, frankly. Yeah, I'm just, there's the point where there's just no point. You people are belligerently religious kooks, and it's just obvious that you rely on this horse shit to tell me what the world does, and you don't have a single physical example of this horse shit producing an accurate answer. Nothing. You just say so. I mean, right here, like I said, it made huge mathematical error. It didn't multiply by the 25 over here. Its numbers were shit. They never check any of this stuff. They never check the two-slit wave math. They never check any of it. They just declare it's the most accurate theory in the history of mankind. We always get right answers. Because you never test any of them. Period. It's just terrible. Yuck. Alright, so what else has to be said? Yeah, there's no... Okay, so first off, this isn't Newton's formula, so that's where the lie starts. The little cross-multiplying gimmick where he doesn't put a unit here. The 1 here, no unit. Yeah, no unit. Nothing to identify one what. You're not multiplying. You're not putting the time, 5 seconds. You're not dividing it by 1. You're dividing it by 1 second. 1 foot wouldn't do you any good. Dividing it by 1 foot, 1 something other. It has to be 1 second. And simply putting that unit back in fixes the whole thing. You get rid of this squared and you get rid of the gimmick. Alright. So anyway, that's the point of the video. So I should just made that simple video and said the hell with it. Because that's where the math goes sideways. That's where they cheat the truth. And such. So, whatever. Whatever. So until we have evidence, there's nothing. It's just going to keep making these assertions that aren't proven by any physical experiment. And so somebody needs to do some physical experiments. Somebody more competent than Brozo, of course. But anyway. So till the next time and such and so forth and whatnot. I don't know why the simple thing to do is just to hit this button. But, I always, I should do this thing first. Alright, anyway, this has been a DraftScience video presentation. Ugh. Sorry, I'll apologize. It's just there's no point. There won't be a counter to the argument. They won't explain why it's okay to put a 1 in with no units. And they could do that in other situations and it won't create catastrophic errors. But of course it would. If they did that consistently, pretended they don't have to put the units in, they'd have all kinds of formulations that wouldn't make any sense. Alright, anyway. So, till the next time.